Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Alright, grade 9s, we are following on from last week's session, which was reactions of metals with oxygen. Now, this week, what we're going to have a look at is the reactions of non-metals with oxygen. Okay, we're going to have a look at a couple of things. Okay, the first thing we're going to have a look at is, of course, the general reaction. Okay, there's a general reaction that takes place when a non-metal acts or reacts with oxygen. And we're also going to have a look at what happens when there's a reaction of carbon and oxygen. So if we have carbon plus oxygen, what happens? And we're also going to have a look at when sulfur reacts with oxygen. What do we get? Okay, so we're going to have a look at this whole topic from that angle. Okay, cool. Or from this angle rather. Okay, now speaking of types of reactions, okay, since we are reacting with oxygen, everybody knows what's taking place in our city right now with regards to the fires that's happening. Okay, I mean, we're not really bringing in political news right now. This is actually a natural disaster. Almost the entire mountain was on fire. Anybody catch some video footage or see some pictures? Anyone? UCT's library's gone. Well, not the entire library, but I mean that one section of the library is burnt down, which is quite close to where the fires were taking place. UCT's library. Anybody wanted to go to UCT in the following years, I'm sure the library will be restored by then. But almost the entire mountain was on fire, and there was also a explosion that happened with a restaurant's gas tank. Obviously, I think everybody was evacuated from the restaurant, but a little bit of an explosion there. Gas tank obviously got doused with fire, and so it exploded. Okay, so that's pretty sad, but that's a type of reaction. And you see what happens if yesterday was quite windy, so the fire spread like wildfire almost. You know, it spread very fast. It was quite windy yesterday as well, and of course, anything with oxygen creates a combustion reaction, and so therefore kaboom. Okay, which is what kind of happened yesterday. Okay, quite tragic. Okay, but enough about that. I believe that the firefighters have contained it, and the spread has stopped. Still putting out some fire, but I think the spread hasn't. It's no longer out of control. So, without further ado, okay, I brought that up because that was a reaction that happened over non-metals. Okay, those were non-metal elements that were reacting there. Okay, but usually to begin, all right, or to begin understanding this, is that when you have a non-metal, okay, when you have a non-metal that reacts with oxygen, I'm going to write out the word form or the word equation. Okay, usually it forms non-metal oxides. Okay, so I think last week when we had a look at it, we had metal oxides formed when metals reacted with oxygen. Now we have non-metals that reacting with oxygen, and they form non-metal oxides. Okay, now examples of non-metals that we obviously will be looking at today is, of course, sulfur and carbon. They are both non-metals. Okay, and they react very slowly in air. Okay, so that's quite good to denote that they react very slowly in air, and we know oxygen is in the air. Okay, they react very slowly in air to form the non-metal oxides, and that's because air only contains 21% of oxygen. Alright, so 21% O2 is 21% oxygen gas. Okay, so it is therefore quicker to form non-metal oxides by burning the non-metals in pure oxygen. So if you have pure oxygen, okay, so pure oxygen, in other words, not just air. Well, that's not pure, that's oxygen. There we go. In pure oxygens, in other words, when you have like basically 100% or close to 100% oxygen, or more than 21% oxygen, okay, and you react that with a non-metal, okay, you'll have what is known as a quicker reaction. Okay, cool. Alright, so now when carbon is burnt in air, okay, so you've got carbon and now you burn it in air. If you burn it in air, what do you usually get? You usually get carbon dioxide, or CO2. Okay, now if we write that equation in word form, we have carbon, alright, and we add oxygen. Of course, we get carbon dioxide. Okay, but of course, in physics or physical sciences, a section of natural science, we want to know the chemical or molecular formula for these. Okay, so we need to write, of course, a balanced chemical equation. C for carbon plus O2, because oxygen exists as O2 in air, we get CO2. Okay, CO2, and CO2 we know is carbon dioxide. We know that very, very well. But basically, carbon dioxide, CO2 there, it is balanced because we have one carbon on either side and two oxygens on either side. So therefore, the equation or the reaction is indeed balanced. Okay, now something about non-metal oxides. Okay, something about non-metal oxides, little side note, is that they may be solid. So let me just write non-metal oxides here. Okay, so they may be either solid, okay, they may be liquid, alright, or gas. Okay, now when carbon reacts with oxygen, it forms the gas. So in brackets I write little g there, because that's carbon dioxide gas. Not liquid, not solid, but gas. Okay, carbon's gas. All right, oxygen is in air, so therefore it's in the gas phase, and then those two combine and create carbon dioxide, which is basically CO2 gas. All right. Okay, so what type of materials give off carbon dioxide? Okay, and it's very difficult to breathe around them. All right, and that is wood and charcoal fires. Okay. So wood and charcoal fires, okay, they give off CO2 gas, and that obviously when they are burned. All right, so around the braai, if you brine, all right, wood or charcoal, all right, it'll give off carbon dioxide, which is very difficult to breathe around if you are obviously around large amounts. So if you have a wooden house and you're stuck in the middle of the house, you'll find it very difficult to breathe, of course, because you're not breathing in oxygen, you're breathing in CO2. All right, so I mentioned those are the substances that give off carbon dioxide, but maybe just to dive in a little bit deeper to the contents, okay? So we said that charcoal and wood fires give off carbon dioxide. Well, not that they necessarily give off just CO2, but within charcoal, all right, we find carbon, all right, which is actually there's actually medication, all right, called medicated charcoal, all right, which is the same as saying medicated carbon, all right, but basically it's almost like I can't remember the exact name, medical name, or I just know that's medicated charcoal or something like that. And basically that is used to stop food poisoning or something like that. So I mean that's used in the medical field, so they've kind of designed it in a way that'll be beneficial to our bodies. But once charcoal is is burnt, of course, that carbon is released. And when carbon is released, it reacts with the oxygen in the air to form CO2. All right. Wood as well contains organic compounds, or is made up of organic compounds. Okay. It's made up of organic compounds, of course, which contain carbon, which we'll learn in grade 12 when we do organic chemistry. Okay, they contain carbon. So imagine now those things are burning with the fire that we're talking about. Lots of trees, wood, okay, was burning. So we saw lots of smoke, all right, or lots of carbon in the air, all right, mixing with the oxygen, all right. Now, when we, as I said, when we burn charcoal or wood, we form carbon dioxide. Now, carbon dioxide, CO2, I mentioned this, it's poisonous. Okay, extremely poisonous. Okay, and it can harm you if you breathe it in. Okay, so if you breathe in large amounts of carbon dioxide, I don't think you'd last 5 minutes if you must breathe in CO2. All right, because our bodies are designed to take in oxygen, which is just pure O2. Well, not pure O2, but I mean oxygen in the air, that 21% of oxygen that exists, that keeps us alive. Okay, but now you add carbon with that to breathe in, and yeah, our lungs start collapsing, and throat starts, or the windpipe starts getting narrower and narrower, and then we end up not being able to breathe. So it's extremely harmful for our bodies. Okay, when we burn charcoal or wood, we cannot see or smell the carbon dioxide gas, so we do not know whether we are breathing it in or not. Although we see smoke, we don't see the carbon dioxide physically. I mean, the gas doesn't have a color. We can't really see it. Okay, all we just see is smoke from the fire. All right, but that's not necessarily CO2. Or, yeah, that's not necessarily CO2. However, we do understand, because of physical and chemical properties, all right, that carbon dioxide gas is being given off. Okay, but you cannot physically see the gas forming. All right, you can't smell it. It has no particular smell. Okay, therefore, if you are sitting around wood or charcoal fire indoors, they always say make sure that we open the door, open the windows, all right, so that air can come in and air can escape. Air can come in and carbon dioxide can escape through into the air, etc., so that we're not breathing in carbon dioxide. Because what we do, we breathe in oxygen and we also release carbon dioxide, and the carbon dioxide is being formed from the wood and charcoal, releasing carbon into the air, and then before you know it, we have no fresh air coming through, just carbon dioxide gas that's existing in the air, and we breathing that in and releasing more, and then before you know it is, or before you notice, you end up laying all passed out on the floor. Okay, so that's very bad. Okay, make sure air is constantly entering the room, or make a fire in the outdoors. Alright, so now we're talking about sulfur now, which I mentioned at the beginning. We will have a look at, of course, we looked at the carbon with oxygen. Now let's have a look at sulfur. When sulfur reacts with oxygen, we get sulfur dioxide. Okay, so again, let's write out the word equation: sulfur plus the word oxygen. Okay, and that gives us, of course, sulfur first, dioxide. Okay, gives us sulfur dioxide. Okay, now we write this in chemical equation. All right, the chemical equation, which I'm sure we all know, is just elements from the periodic table, and it is perfectly balanced already. Well, we have S for sulfur plus O2. That gives us sulfur dioxide, which is SO2. Remember the di in dioxide meaning two oxygens. Okay, makes sense. Okay, so that's as easy as that. Okay, so my question that I'd like to pose, as a little bit of a quick research task right now, if we can. All right, because I'm sure we all have access to the World Wide Web, otherwise known as the internet, right now in class. Can someone maybe do a quick research and tell me, is sulfur dioxide harmful to us as human beings, or is it harmful? Is it poisonous? Is it not poisonous? All right, and some of the damages that it can do. And then I'll wait to hear a report back. Would the student who found out the answer, would they care to repeat the answer, please?
It's toxic to humans.
Okay, it's toxic to humans, so it's poisonous. Do they mention what could happen if we ever come into contact with sulfur dioxide? If we drink it, if we breathe it in, what will happen?
They say that it's fatal.
Ooh, it's fatal. All right. So, like carbon dioxide, sulfur dioxide is also fatal when breathed in, okay? Because this is also in gas form as well. So it is also a fatal. I was thinking of the word lethal, so I combined both of those words together. It's a lethal substance and harmful substance if breathed as well. All right, sulfur dioxide. Okay, so also, Caitlin, do they mention in your little search there what if sulfur dioxide has a color? Can we see it, or does it have a smell? Can we smell it?
Oh, I don't know that part.
Okay, cool. All right, that's fine. Thanks, Caitlin, for at least starting this process. So my next question, with a quick research, does sulfur dioxide, can we smell it? So can we smell that? That's sulfur dioxide. That's bad. I need to get out of here. Or can we see it? Does it form a specific color? All right, let's see if we can find out that answer. All right, Caitlin, if you have an answer, you can share it.
It doesn't have a color, but it smells like burnt matches.
Ah, okay. It smells like burnt matches. Okay. Excellent work there. Thank you, Caitlin, for sharing that with the class. Cool. Okay. And that's basically it, guys, of the reactions of non-metals with oxygen. Okay. In terms of content. Okay. Have a little bit of a Q&A. Okay. That will take up probably just about 10 minutes. All right. Wondering why is it doing that? There we go. It'll take up just about 10 minutes. Okay, so my first question. All right, let's see if we can answer this. Okay. Can I please get the general word equation? Okay, I would like the general word equation for the reaction of metals with oxygen. Okay, and non-metals with oxygen. So I want the word equations for both of those. Okay, so that's question 1. Okay, stand by for question 10. Okay. Let's see. Okay, so here we go. Write one equation for the following. Okay, so 2.1. And when I say write an equation, I mean write one chemical equation. Okay, that word means this little symbol means I left a word out. Write one equation, chemical equation for a non-metal. So you can pick any one plus oxygen. And then 2.2, of course, a metal plus oxygen. Okay, if you remember the general formula for both, you'll be able to answer these 1-2 questions. All right, go. Alright, let's give this a mark quickly. So the general word equation for reaction of metals metals with oxygen and of non-metals with oxygen. Okay, cool. So, well, we know when we're talking about general formula, we know that we have a specific type of metal, of course, that's going to react with oxygen and needs to give us something. Okay, so if we go here, we just have a look at the solutions. Okay, for one, this is for the metals. Now we're going to have a metal that's going to react with oxygen, and then it's going to give us a metal oxide. Alright, the same goes for non-metal. It's going to have a non-metal that's going to react with oxygen. Then it's going to give us a non-metal oxide. And I'm sure we got this one right. If we're confused about the top. Yeah, that was the question. Give me the word equation, the general word equation for metals with oxygen and non-metal with oxygen. That was it. Let's have a look at the question again. The general word equation for the reaction of metals with oxygen and non-metals with oxygen. Oh, my bad. Pretty cool, eh? Alright, so that was that one. And now the next one was write one chemical equation for one non-metal and plus oxygen, and then choose a metal and give me that equation as well. So with this one for number 2.1, would like to have a shot at 2.1, which is the metal with oxygen. Any metal that they'd like to it already reacts with oxygen, so I'm going to give put O2 here. Okay, I just need to know which metal. Let's make sure that question. No, sorry, 2.1 was a non-metal. Sorry, with oxygen, non-metal. All right, well, I'll give you an opportunity to fix yourself and redeem yourself. Okay, cool. So tell me the name of the or the word. So write down the non-metal that you chose. What was it?
Carbon.
Carbon. Okay, so what's carbon symbol on the periodic table?
CO2.
Well, C for carbon, and then the product would be CO2.
Yeah, C.
Yeah, there we go. Okay, cool. Cool. So just get that down for a non-metal. Did everybody else choose a different element here? Did anybody choose something else? Amber or Uzair?
I chose sulfur.
Oh, you chose sulfur? Okay, yes. So I'll put ore. You can have sulfur plus O2 and give us SO2. Okay, cool. Fantastic. I think Uzair looked like you chose carbon as well. Okay, very good. And for 2.2, now we choose the metal. Alright, the metallic. Alright, cool. Anybody like to take a shot at this one? 2.2, any metal plus oxygen. Okay, anybody else?
Iron.
Iron, okay, so iron, we got Fe. And when we react iron together with oxygen, okay, we have Fe2O3. And now this one we need to balance, don't we? Of course, iron that's reacting with oxygen, Fe plus O2 gives us Fe2O3. Okay, and of course this must have been the iron 3 atom. Okay, element. So we need to balance this one. So we know that I need to double up this one here, and that must be a 4, and that must be a 3. All right. Oh, forgot to write my plus. My goodness. There you go. Separate those two. All right. Excellent. Cool. All right. Any other metals such as magnesium would have also worked. Okay, we have Mg plus O2, and put together that becomes MgO. Okay, then after MgO, you have to just balance that equation as well to 2Mg and 2MgO, And there we got ourselves a balanced equation there. Okay, cool. Okay, thanks for answering the questions, guys. That took exactly about 10 minutes. Okay, so it's just something I just want to share with you guys with regards to when I asked the question about the color and smell of carbon and sulfur. Okay, and I found some good information that I saved toward the end of the class. I'm just going to go find that picture quickly. So this is the little picture, okay, of what is known as a deflagnated or deflagrating spoon. It's just like a little spoon that looks like a soup ladle almost. Okay, and we use that to burn certain elements and put it into a beaker or to a jar, okay, that has pure oxygen in it. So scientists actually collect pure oxygen from an oxygen tank, and then they insert that into a jar of some sort, and then they get a deflagnating spoon. And on the deflagnating spoon, they burn a certain substance. Okay, so they'll put carbon in the spoon, and they will burn it under a Bunsen burner, and then they will, once the substance starts burning, they will insert that into a jar with a lid on, okay, so that the element can burn. And in carbon, when carbon burns in pure oxygen, we actually get an orange yellowish flame. Okay, an orange yellowish flame, okay, that collects in the gas jar. Okay, so there is a color. Okay, and then when sulfur burns in oxygen, we get a bright blue flame. All right, and the gas sulfur dioxide collects in the jar. So we can clearly see by this little experiment what is currently burning. Is this carbon that is burning, or is this sulfur that is burning by the bright blue flame? Which substance is it? What color is it? Is it blue or is it orange? All right, it's blue. All right, so blue means carbon or sulfur. What did I just say? Carbon or sulfur? Choose. Guess. It's okay. I'll tell you if you're wrong if you are. Anybody?
Sulfur.
Well, then you are right. Okay, blue flame, sulfur. Okay, sulfur is blue. And then, of course, you get orange. The orange flame, that is your carbon. Okay, carbon that is burning. And then the carbon dioxide gas will collect in the jar. Okay, but carbon burns orange in oxygen, and sulfur burns bright blue in oxygen. Okay, that was recorded, so if you listen to the recording later, you'll find out, or you'll hear that answer again. Now, we don't do this experiment in schools because it cannot be done safely in most classrooms, so we don't really do this experiment in schools. Otherwise, if the kids in the class breathed in the gases, they can harm you. Okay, and sulfur dioxide is very dangerous to people who have asthma. If you have asthma, sulfur dioxide is very bad to be around. You need to clear out of there, otherwise, yeah, you're not going to be on this earth for very much longer. Okay, so that's my warning and bit of caution. Okay, even if you don't have asthma, you don't want it, so you don't want to play with your breathing. Okay, if you smell something funky and you know it smells a bit like close to or remotely close to matches, get the heck out of there. But as for that, guys, that concludes my presentation for this evening on reactions of metals with non-metals. All right, and next week we review where we are at in our syllabus, and if we need to go back to bio, we will. Otherwise, we will continue with acids and bases and pH value.